Okay, so in these examples, it says to assume that all of the triangles below are right triangles. Find the missing sides using the properties of the special right triangles that we just talked about. So this first example is an example of a 45, 45, 90. We know that this would be our 90-degree angle, and then the other missing angle would have to be 45. We're given the hypotenuse, and it's asking us to find the other two missing sides. So you have to recall the sides of a 45, 45, 90. We're given the side across from the 90-degree angle. We know that the side across from the 90-degree angle is equal to x times the square root of 2. So with these types of examples, you're always going to set up some sort of equation and then solve that equation for x. And then once you have x, you should be able to plug it into the other sides. So we're going to set then that 5 square root 2 equal to x times the square root of 2. And then we just want to solve our equation for x. So we would divide by the square root of 2. And we know that those square roots of 2 are going to cancel out. So x is just equal to 5. And then we want to find the other two remaining sides. So the side across from the 45, recall that's equal to whatever x is equal to. So this would be 5. Same thing here. This would be 5. So those are our two missing sides, 5 and 5. Okay, let's try another example. This second example is also a 45, 45, 90. So I'm just going to fill in those missing angles. Except this time I'm given the side across from the 45. So I know that the side across from the 45 is equal to x, so my equation would be x equals 7 square root 2. Now I don't need to solve that for x because it's already solved for x. I just need to find the other two missing sides. So I know that the other side across from the 45 is going to be equal to x, so that's 7 square root 2. But then the side across from the 90, that's equal to x times the square root of 2. So to get x times the square root of 2, we would have to multiply both sides of this equation by the square root of 2. So the x square root of 2, this would be equal to x times the square root of 2. Sometimes it's hard for people to visualize, but remember this was x, and then we're multiplying it by the square root of 2. So to simplify this, I get 7 square root 4, which is the same thing as 7 times 2, which is 14. So 14 is our side across from the 90. Alright, so I do want you to eventually try some examples on your own, but before we get to that, I want to look at our second type of special right triangle below, the 30, 60, 90. So let's try this first example over here on the left. I'm going to fill in my missing sides, so I know that's 90, this is 60, and then I'm given the side across from the 30. Well, recall the side across from the 30 is equal to x. So I'm going to set 14 equal to x. I don't need to solve that equation, it's already solved. And then I need to find the other two missing sides. Well, the side across from the 90 is equal to 2 times x. So to get 2 times x, I just need to multiply 14 times 2, and I get 28. So 28 would be the side across from the 90. The side across from the 60 is equal to x times the square root of 3. So I need to take x and multiply that by the square root of 3, and you get 14 square root of 3. So now I found my two missing sides. Okay, let's try another example. And if we skip over to the next one, this is 90. This is 60. And we're given the side across from the 90. The side across from the 90, recall, is equal to 2x. Now I need to solve this equation for x, so I'm going to divide by 2 to get x equal to 10. Remember that the side across from the 30 is equal to x, so that would be 10. The side across from the 60 is equal to x times the square root of 3. And now I'm finished. So what I'd like you to do now is pause the video and try the remaining examples on your own. Some of these are going to be a little bit challenging and you're going to have to simplify completely in order to get your final missing sides. So pause the video now, press play when you're ready to check. Okay, so if we look over here all the way to the right at this third example, we are given the side across from the 90 and a 45, 45, 90. So I know the side across from the 90 is equal to x root 2. So here's my initial equation that I set up. 10 is equal to x square root 2. Now to solve that equation for x, you have to divide both sides by the square root of 2. But I can't leave my answer as x equals 10 over the square root of 2. So to get rid of that square root in the bottom, I multiplied the top and the bottom by the square root of 2. So then I kind of move down here and I get 10 square root 2 over the square root of 4. And I need to clean this up and I get 10 square root 2 over 2. And then I can divide 10 divided by 2 to get 5 square root 2. So this one, when you solve for x, you get x equals 5 square root 2, and that's what I was looking for. For my two missing sides, those are the sides across from the 45s. So those are both going to be equal to 5 square root 2. So those ones are a little bit trickier when you have to divide by a square root and then you have to also rationalize it, because keep in mind you can never have a square root in the denominator of a fraction. Right below it, if we look at this third example of the 30, 60, 90, we were given the side across from the 30. So I know that that side across from the 30 is equal to x. So here was my initial equation, x equals 2 square root 3. Now I can't solve that, it's already solved for x, so to find the side across from the 90, I need to multiply x by 2. So that's how I got 4 square root 3 for this side. And then the side across from the 60, I have to take x and multiply it by the square root of 3. And that's how I got 2 square root 9, or 2 times 3, which is equal to 6 when I simplify completely. So those were your two missing sides in that example. Now the last three examples, if we take a look at this next one, this is very similar to the first one I just went over. My initial equation, I'm given the side across from the 60, so I had to set 12 equal to x square root 3. Then when I go ahead and solve that for x, I'm going to divide both sides by the square root of 3, and I can't leave my answer like this, so I have to multiply the top and the bottom by the square root of 3, and so I get this down here, 12 square root 3 over the square root of 9, which reduces to 12 square root 3 over 3, and then I can divide 12 and 3 to get 4 square root 3 for x. The x always goes across from the 30, so that's one of my missing sides. The other missing side across from the 90 is equal to 2 times x. So if I multiply that by 2, that's how I got 8 square root 3 as my other missing side. The next one only had tick marks on the sides, but right away you should notice this is then an isosceles right triangle, which is also a 45-45. The side across from the 45 is equal to x, and I can't simplify that any further, so my other missing side across from the 45 is also equal to 3. The side across from the 90 is equal to x times the square root of 2. So those were my two missing sides in that example. Now this last example is also a 45-45-90. I'm given the side across from the 90, which I know is equal to x root 2. So here was my equation, my initial equation. To solve for x, I divided both sides by the square root of 2, which canceled out to give me that x is equal to 17. So 17 are my two missing sides. So hopefully now you have a better understanding of the two different types of special right triangles. Please make sure that you take time to memorize both the 45-45-90 and the 30-60-90, because you're going to see these used not only in Chapter 9, but also in every remaining chapter from this point on.